Hello, I am Dr. R. K. Shankaranarayanan, Assistant Professor, Department of Chemistry, SNH, SNS College of Engineering. Here we are going to discuss about infrared spectroscopy. It's related applied chemistry. Infrared has multi application field. What is the rays and where it's applicable, what are the regions. So all the concepts will involve in the discussion. First, what is infrared spectroscopy? Generally, we make it a shortly we used to call as a IR spectroscopy. It's a very great technique to analyze the materials and organic substances, some inorganic substances. So generally what will happen, that the principles of IR spectroscopy is mainly interaction of the material. Okay, just take the infrared rays with some matter, or matter means it may be some substance. Okay, that what will happen, that matter what it will do, that absorption of IR radiation by any substance, if it is some inorganic or organic molecules, whatever it is, it will absorb and it will go to there will be some changes will happen due to the infrared rays. Okay, that we call as a vibrational transitions. Once it's absorbed the energy, it automatically it will go to the vibrational transitions. So based on vibrational transition, we can find the materials, whether OH group is there or NH2 group is there. So whether it is scissoring or wagging, so many concepts are there. So based on the IR infrared spectroscopy, there will be a bond length change, will be the stretching and bending. Bending means bond angle and stretching means bond length, especially whether it's elongated or get reduced. It will just think about oxygen and water molecule. The oxygen will be fixed, that two hydrogen it will go up and one will go up, another one will come down. Okay, or it will go to right and left. So these are the stretching frequencies. Okay, and how it's going to affect dipole moment? There will be changes in dipole moment. Dipole moment, what you call that splitting of positive and negative charge, how it's expanded. Okay, that we call as a dipole moment. And what is the IR regions? 400 centimeter to 4000 centimeter inverse. Okay, so this is the vibration range of infrared spectroscopy. So in the concept instrumentation, IR radiation generally what will be the source? Nernst globe and silicon carbide, that we call as a globe. Okay, that will emits a broad spectrum of IR radiation, that you can see the lamp in the diagram. It's a very small lamp. Okay, that will be the source for the IR radiation. IR means what it means? Infrared radiation source. And sample holder. Sample holder, if the sample is getting powder or crystals, we have to mix with KBr. KBr means potassium bromide. We have to make it as a powder. We have to make it as a pellet. Like thickness will be just our 1 rupee coin. We have to make it half of the thickness. Okay, we have to give the weight load to make it. It's like a slide, very small slide. It's equal to 1 rupee coin size, but the thickness will be very less. And liquid also we can do the infrared FTR, we can do it. Okay, so another one is, so these are the things that we are using. And one more method is called ATR method, alternated total reflectance. This is infrared Fourier transformer infrared spectroscopy. Another one is monochromator. What is mean by monochromator? There will be a specific rays will come out from the source to hit the material, that will come out. So that is called the monochromator. Okay, here we are using prism or creating the monochromators to get specific wavelength, which means that 400 to 4000 centimeter inverse. And detector, what will be the detector? Thermocouple bolometers and pyroelectric detectors. So these are the detectors, and recorder generally what we are using computer, just we are getting the graph in the computer. So that will be the recorder. So here you can see the IR spectroscopy instrumentation flow chart. Here you can, that red color ball is the IR source, and once light once started, it will go to the reference and samples. Okay, based on the reference it will nullify the errors, and only you will get it the which one, only we will get the sample vibrational stretchings through. So it will split the only with the specific wavelength, that why we are using monochromator. Thank you.